Hi, my name is Antonio Dimaggio, and I'd like to welcome students, staff, and faculty members of Portland State University to this presentation on the Autobug tracking software that we made for our computer science capstone program at Portland State during the spring and summer terms of 2020. I'm the team lead of this project, and my software engineers are Ramon, Princess, Mahmoud, Ryan, Donna, and Armando. I'm going to pass the presentation off to Donna for a description of the project as well as a demo. So thank you for watching and I hope you enjoy.
Thank you, Antonio. My name is Donna, and I'll be going ahead and discussing the description of our project and then also followed by a demo. The proposal came about from the idea that software is buggy, and when software is buggy, it can result in users moving away from their project and or the user experience. On top of that, they don't have bug trackers, so we were asked to go ahead and create a automatic bug tracking software that can be easily attachable to any existing project or software. The solution that our team came up with was called the AutoBugTracker, which simply attaches to the program of the developer's choice. Then we'll be able to automatically track bugs that occur in the developer's program. Based on any bugs that come about from the developer's program, we go ahead and handle that through sending GitHub issues and or send email notifications. There are 3 points that the sponsor really emphasized on during our meetings, and that was having the program be attachable, extensible, and also automatic. And with that being said, we'll go demo our auto bug tracker that we were working on for the past 2 terms. A test program running here, which is going to log some errors, raise an exception, and log some more errors. And we'll go ahead and click play. Once clicking play, it will go. We can actually do side by side right here. 1 second. This will require an encrypted message, so we'll go ahead and it takes in the first log error, and then it'll also take in the other errors as well. So there's log test 2 or local test 2, another error. And as you see it on the right, we are currently getting emails as they're coming in. And it's again raising another exception. And if we go ahead and take a look at our server side, it was able to listen in and grab every single of those log errors that came about from that test program. Also, one thing to keep in mind, our server-side program most likely will never ever turn off. It'll keep running and listen for more. So hypothetically speaking, there can be multiple instances of local bug trackers running, and they can just point to the same server for one team, for one company, and they can be separated out accordingly. So we can go ahead and now take a look at our emails. If we go ahead and we see we got 3 emails. We get the first log error, we got the local test 2, and then we have the whole trace back from that exception. And we can double check that is the 3 errors that came about from this test program. We can also go ahead and take a look at our database. Currently it's empty. If we do a select star from bugs, we should see, that's semicolon, we should see 3 instances or 3 rows within this table. We have 1, 2, and 3. Apologize for the formatting, but just to prove that it is there. Now we'll go ahead and take a look at our issues, where we'll go ahead and click a quick refresh. We have again issue submitted for the log error, issue submitted for the second log error, and then the issue submitted for the exception. And we can also do one more thing where to just showcase that it won't submit bugs twice and it won't report it twice. If we run the same thing again, we should not receive any notifications through email or GitHub or submit it to our database because it's already been submitted. We still will show it on the console. That's just proof and for demo purposes that, hey, we are still listening in to these errors and our server is still running. If we've kept an eye on the right side, there has been no email pop-ups and we have any more issues. We should only have 3, and that is the case. We only have 3 issues. They have not been submitted again, and that's only 3. Same thing with this. We only have 3 and it has not been submitted again. And then we'll go ahead and take a look at the database as well. We should only have 3 rows submitted, and there should be no more, again, 3 rows. So there is no duplication of bugs being reported. I hope you guys enjoyed the demo. If there's any questions, please don't hesitate to reach out, and we'll be glad to answer any questions. Thank you.
Hello, my name is Armando, and I will be speaking to you about target audience, project overview, and the key features. So, most projects do not include implementing their own independent bug trackers. That's usually left for junior developers or interns, and it's not something that's part of the software stack per se. AutoBugTracker is distributed in mind to support team-focused environments. They don't have to stop, halt development, and focus on a minute bug that has nothing to do with the big picture. So the project overview, AutoBugTracker can attach it to programs you want to trace bugs from. It acts as a server, waits and listens for any bugs that the program may encounter, and then acts accordingly depending on your current configuration file. And it has different options and features that you can turn on and turn off to better work with your current environment workflow. And those features are bug detection, of course, a local and server environment. Both of these environments are modular. Blacklisting capability, they can filter out for specific bugs. Also have, you can update to a database and then keep track of that. And then you can also, if you have if your environment is hosted on GitHub, depending on the bug that you encounter, you can open up a GitHub issue, and you can also elect to email yourself for the team.
Hello, my name is Ryan Campbell, and today I'll be talking about 3 different slides on our program, the AutoBugTracker. To start with, our program, the AutoBugTracker, is designed to attach to a program that you are trying to constantly track bugs and errors from. The intent of our program is to attach it to a process that you're running, and our program will sit there and listen, and whenever a bug is detected, it will then capture that traceback information and send it to the server for processing. So our program has 2 repositories. They're local and server side. The local repository is called AutoBug Local, and the server repository is the bug tracker. The local side's job is to listen for the bugs and then send that traceback info to the server, and the server side's job is to send the traceback info to the developer's GitHub and email through a maintained Postgres database.
Hey, my name is Ramon Guarnes, and I'll be talking about our implementation of the blacklisting feature. This feature resides within the local side of our project, and with blacklisting, you can specify which errors or acceptances will be excluded from being submitted as a bug to the server. The functionality starts from reading a custom text file called black.list, where the user is able to manually put the traceback information of the error they don't want being submitted. Each individual traceback info must be separated by the specified delimiter, which is defaulted to 2 new line characters. When the error is detected after the listing process, the traceback info of that bug will go against the blacklisting process, in which it checks whether that traceback info matches any element in black.list. If it does match, then we do not send it to the server and go back to the listing process. If it doesn't match, it is clear to be sent to the server.
We designed our database using PostgreSQL, and then what we did is we used another open source project called Docker. Docker is a great way to create an isolated environment for applications that you want to run inside of them. It's sort of like a virtual machine, but it's has a smaller scale. It doesn't take as much resources, doesn't need its own OS. You can just create, in our case, we created a PostgreSQL container, and then you just connect to that container, and you can create databases on it. You can connect to different databases, but in our case, we only had one database, and that's all I got.
Hello, my name is Princess Kim, and I'll be presenting the next few slides here. A key part of AutoBugTracker is its ability to notify users of new bugs. You can have a GitHub issue be sent to a repo of your choice by supplying the repo name and your access token, and setting the Send to GitHub option to True in the configuration file. You also have the option of receiving an email that details the bug report by setting the Send email option in the configuration file to True and supplying it with an email. If our team had more time to, we would pursue implementing features like enabling users to pip install the AutoBugTracker with proper Python app conventions. We'd also want AutoBugTracker to be able to capture outputs from programs written in languages other than Python, like C++ or Java. AutoBugTracker would be easier to use if the configuration file could be changed via command line options, and further expanding the notification system to automatically send an email when a GitHub issue is resolved would make the app feel more complete. Now that we're done talking about what AutoBugTracker is, we can discuss a little bit more about how AutoBugTracker was created, including the steps it took for our team and the struggles that came along with it. I'll be passing the torch along to Mahmoud, who will begin talking about AutoBug's architecture.
Hello, this is Mahmoud Robiai. In this slide, I will speak about the initial bug tracker program architecture, which is communicated to us by the product owner. The idea is simple: a program that is designed to listen to a user program and capture whatever bug could be generated from that user program. The bug could be coming in different format, exception, segmentation fault, or any type of errors. Once the bug got captured from the user program, it will be communicated to another program that living in the server side, which is by its role will handling the communication of that information to a GitHub as well as to updating the database with that information and email it to a user. In this slide, the diagram has captured the actual implementation, which has covered all the required features. The AutoBugTracker is designed to listen to a user program, and once a bug is found and it's not blacklisted, the bug tracker program server side will capture and communicate the traceback info to the bug database. In addition to that, the server program designed to check the config file set by the user prior to the execution to include whatever user configuration put together to send the bug information. The user can configure the bug info to go to GitHub as well as to send in an email. Important to highlight, a log file will be generated to capture all necessary debugging logs for all execution lifecycle.
Okay, so I'm going to go ahead and discuss the development process that we adopted during our development of the AutoBugTracker. We went ahead and went with the Scrum Agile methodology to go ahead and develop the AutoBugTracker. We had an Azure Task Board by Microsoft that had PBIs, product backlog items, where each of them had a dev task and one QA task and two pull request tasks. The process we had was where the dev would go ahead and do the work. Once it's done, two people that are assigned to pull request reviews will go ahead and review the code and then go ahead and then approve. And then from there, the QA will go in and test and make sure that has been added to the AutoBugTracker. We were on 2-week sprints where we would hold a retro after every second Friday of the sprint to close it out so that we can go ahead and improve on the next sprint. We held Discord meetings every Friday and or Mondays, and we are also actively meeting and communicating with our sponsor.
So during development, everybody participated in every aspect of development, from writing code to testing code and reviewing code. Most of these tasks were actually distributed by myself as team lead, and some were volunteered. Additional tasks would include things like making slides or presentations or even putting this video together. After every sprint, we would review what we did well and what we could improve on. And I'd like to give thanks to Donna for this entire process. He stepped up early on to help the team out with the Scrum and Agile process to help keep it professional. And I don't know where we'd be without him. So thank you, Donna. We had some unexpected events during development in addition to the COVID-19 crisis, and these were things like Windows compatibility issues, which we ended up resolving with the WSL Windows subsystem for Linux, and we used the Ubuntu distribution of Linux with that package. We also had tight deadlines. Some features required other features, and so we had developers that were waiting on their teammates to finish things up, like testing, and this kind of slowed development down a little bit. We also had features that had to be dropped or stretch goals that had to be dropped because of time, and some features didn't come out right the first time because of the transaction of details. One engineer explains things to another engineer, and then he explains it to the next engineer, and details are lost during that communication. And all of these things kind of put a strain on development, but I think we were successful overall.
Next up, I'll be talking about the lessons we've learned throughout our Capstone endeavor. The first thing we learned about is that our team needed foundation. Of course, during the beginning of our Capstone, we were uncomfortable with each other, and we really didn't have any idea of each other's skills and capabilities. It also didn't help that the coronavirus prevented us from socializing in person, meaning our only interactions were through voice and video calls. But once we started building trust between each other, that's where we felt much more motivated to work as a team. The second thing we learned about was that our team needed good communication. Miscommunication was a common occurrence during our development process, which hindered the completion of some of our product backlogs. It was important that we made an effort to make sure everyone was on the right track when presenting each other's work, so that way everything in our project would seem clear and concise for everyone to understand. The last thing we learned about was that our team needed good productivity. Collaborative sessions like pair and mob programming helped us get motivated, which streamlined the amount of work getting done. It was clear that some product backlogs needed to be halted because it depended on the completion of someone else's work. This meant that there were times where we didn't get to succeed in keeping the efficiency going, which led to tight deadlines, which also led to stress. We also have a word from our sponsor, Daniel.
Hello, my name is Daniel Connolly. I am the Capstone sponsor for the AutoBugTracker software. I'm just doing a little retrospective here for the team. So these are the features that I generally asked for, and as you can see, a lot of the check marks, a lot of them I got. So it was really a good experience overall. Attachable, extensible, automatic, those were like my 3 keywords. And I also got some really good features, such as emailing developers, emailing users if they choose to include that into their AutoBugTracker configuration file. It integrates with Github, and it counts bugs and submits reports and doesn't duplicate reports. So it's really, I'm really happy with the results generally. Yeah, so like I said, great experience. I'm just looking at some of the positives and negatives. Easy to work with students. I was able to talk about my position as a sponsor in an interview, and I got the job. So maybe that had some positive effect on me. I didn't have to be super involved. I also plan on extending this project out per a student's suggestion and modifying it and trying to kind of sell it but give it away for free for a time. I think it could be really useful to people, and if I extend it, even more useful. Some minor feedback: I think the installation could have been some more simple if a lot of the commands were put into a bash script, and then some minor Python optimizations could have been completed. But generally, it's easy to use, the config files are great, and I would definitely be a sponsor another time. Thank you.
Now I would like to take this time to thank Bruce, Daniel, and Teal for granting us the opportunity to experience the challenge of Capstone. While the skills that we developed as a result of this project is something we won't take for granted, especially to the members who are about to graduate, to members who are starting to forge their career paths, to those already providing their skills in the workforce. I'd also like to give a personal thank you to the AutoBugTracker team. We finally completed Capstone, and I really couldn't have asked for a better team to work with. Each individual team member has definitely provided towards this greater accomplishment. Thank you.